Okay, let's go to problem 3 here now in this mastery section. This is, we'll read through this. We're going to find that this is again a test on means, but this is a test on paired means. If you just look at the data before we read the problem, I may sort of have to read the problem. Let me do that. The football coach at State University wishes to determine if there is a change in offensive production between the first half and the second half of his team's recent games. And he's going to judge that just based on the total yards that his team achieved in the first versus the second half. The table below shows the first half and second half offensive production measured in total yards gained per half for the past 6 games. So what's different now is that this data is paired in this sense. If you look, for instance, in the first column, you've got 93 yards in the first half, 65 in the second half. What pairs them is it's the same team, same game, first half, second half. All right. That's, in that sense, there's a relationship between these two. There's a relationship between these two bits of data, and we're going to treat things a little differently because in these cases, when we're dealing with means, paired means, we're going to always be asking, is there a difference between the first half yards and the second half yards by judging those paired means? So the null hypothesis is always going to be mu1 minus mu2 is equal to 0. And then the test can be left, right, two-tailed, just depending on what you're interested in. So if I handle problem A, this is a problem associated with two means from two dependent populations. The dependency is, again, through the fact that these are these are the same team in all cases. The null is mu1 minus mu2 is equal to 0. The question says, the table below shows, the coach wants to determine if there is a change, so he doesn't care up or down, he just wants to know if those are the same or not. So the alternative hypothesis is mu1 minus mu2 does not equal 0. That makes it a two-tailed test. And these tests, you deal with the are t-tests on the differences. So what do I mean by the differences? The differences are the first row minus the second row, mu1 minus mu2, and that those means themselves are then all averaged, and you create something called mu sub d. Yeah, and what we're really asking then is mu sub d equal to 0 or is it not? So before I start to get into the t-test, I have to calculate those differences. 93 minus 65, what's that? 18. 126 minus 126 is 0. 142 minus 121, 21. But rather than doing that, let's turn to the calculator, and I'll show you the typical way to do that. Once we have those differences, since we're going to run a t-test on those differences, that t-test is going to require that we know the mean of those differences and the standard deviation as well. So let me switch modes here and let's run through how we handle this problem on the calculator. All right. Okay, so let's take on problem 3 here. The first thing you have to do is find those differences, and again, that's a step that you don't have in the other types of hypothesis test type problems. So in this case, let's just go to edit, and you can see that I've sort of saved you seeing all the sausage being made because I've entered the data. I've entered in list 1 the data that is associated with sample 1, all of the means in sample 1, a 93, 126, 142, 128, 113, 94, and in list 2 I've done the same thing for the second sample. So what you're interested in now doing is finding the difference in all the matched pairs. So let's go over to list 3, go right up to the very top, and let's just enter L1 minus L2. And guess what? When you enter that, it will, in each one of the 6 spots in L3, it'll enter those differences. 93 minus 65, I think I called that 18 earlier, it's 28. 126 minus 126, 0, 142 minus 121, 21, and so on. And so now let's do this. Let's go, what I need to do now is one variable stats on list 3, on those differences. So I'm going to go back to edit, I'm going to go to calc, I'm going to go to one variable stat, and it asks me what data, and I say list 3. I don't have to say anything about the frequency, I just have to then calculate. And now I've got to write down off to the side, I'm reaching back over to my desk here, I'm going to put down that x bar is equal to 16.333, and I'm going to put down that the standard deviation is 9.585. 9.585, yeah. And n, of course, is equal to 6. But now I'm ready to go over to the t-test, back to stat one more time. I've gone to edit, I've gone to calc, we might as well go to tests, go down to t-test. I'm doing a t-test on that one variable stats data. And so let's see what it asks for. It asks first for mu0, and it's set equal to 0. That's what mu0 is. Mu0 is essentially mu d in this case, and we have assumed that that's equal to 0. And you can see what's very nice is I'm going to say, yes, I just want stats. Mu d is indeed assumed to be 0 in the null hypothesis. There's the x bar of the differences. There's the s of the differences, and we're doing a two-tailed test. So I come over to calculate, and I'm interested in that p-value, and that p-value is 0.0087 or 0.009, and 0.009 is less than alpha, which is 0.05. So we are again in the critical region, and we reject the null hypothesis. We reject the null hypothesis. And for that reason, then, yeah, there does seem to be a difference in the first and second half. All right? And that takes care of problem 3.